rational and irrational numbers is the main topic. You will be able to classify numbers and then also be able to solve problems involving exponents and square roots. So we'll touch on that for just a little bit also. First thing we're going to talk about is exponents, which might be a little bit of a review, which is fine. A power is the base and the exponent combined. So in this example, it would be this whole thing here, the 5 and the 3. I'm going to skip exponent for just a second and talk about base. The base is the big number here, the 5. Okay, so it's the big number that is involved there. The exponent then is the small number. Okay, it's the small one that's raised up. And that is saying how many times, and I'm going to run out of room, but to multiply the base. Okay, so let's do an example here with using 5 to the third. That's saying 5 times 5 times 5. In other words, I'm multiplying the base 3 times. And then I can do this. 5 times 5 is 25. And then 25 times 5 will give me my answer of 125. So 5 to the third is 125. Another example would be if I did 9 squared. That would be 9 times 9, which is 81. 5 to the first power means I have 5 one time. So my answer is just simply 5. 5 to the 0 power is the oddball. It actually is going to be just 1. Anything to the 0 power is in fact 1. Alright, square roots. It is the opposite of squaring a number. In other words, it undoes that. So how this works, you take the number inside the square root sign and you want to figure out what number multiplied by itself is going to give you an answer of 16. In this case, it would be 4 times 4, which is also 4 squared, which is why it's undoing. And that means the square root of 16 is 4. Another example for you, square root of 9. What number times itself, or what number squared? That would be 3. 3 squared is 9. So the square root of 9 is 3. You can also have times where it is not a whole number. It's not a perfect square. So the example of the square root of 30. This is not going to give you a whole number answer. I know that because the square root of 25 is 5. And the square root of 36 is 6. And 30 is right in the middle of both of those, which means you're going to have a decimal of an answer. But you can estimate that the square root of 30 is going to be between 5 and 6. So like 5 point something, like 5.5 along those lines. But using the perfect squares that you know that will give you integers are helpful. And this is something that you will see on IXL as well. Alright, 4 practice problems, 2 square roots and 2 exponents. Go ahead and do these problems and then check in with me for the answers when you're done, so pause the video. Alright, here we go. Square root of 36 is 6. Square root of 144 is 12. 2 to the third power is 2 times 2 times 2, which is 8. And 7 squared is 7 times 7, which is 49. Okay, now we're going to talk about rational and irrational numbers. Rational numbers are any number you can write as a fraction where the denominator is not 0. That's really important to know that it's not 0. In decimal form, so if it's not written as a fraction and it's written as a decimal, the decimal has to repeat or end, which is terminates, that's the fancier word. So let me give some examples of that. You could have like 3/4, okay, because that's a fraction, so that's a rational number. You could have 3.29, okay, because the decimal stops after the 9. It doesn't keep going. It could also be, let's see, 0.212121 because that repeats over and over and over. Another one could be, let's see, -5. Okay, would be another rational number because -5 you can write as a fraction, -5/1, and as long as the denominator isn't 0, you're good to go. Alright, then there are other types of numbers inside rational numbers, and that's natural, whole, and integers. Integers should stand out to you since we've been working with that. That is basically all positive and negative numbers. Okay, and that's what we've been dealing with. So examples would be like -2, -1, 0, 1, and 2, and so on down the number line. Think the number line when you think integers. Then you have whole numbers. And whole numbers are very similar, except they don't have negatives. So it's 0, 1, 2, and so on. The way I remember that is the whole has an O in it, and that O looks like 0. Okay, so that's the way you can remember that one. And then natural numbers. If you think of natural numbers, how do you naturally start counting? Well, you naturally start counting by 1, 2, 3, 4, and so on. So the definition there is counting numbers. Okay, so think about you think about your hand. And that's a terribly drawn hand, but that's what you think of when you hear natural numbers. Okay, then we have irrational numbers. So an irrational, actually just means not. Okay, so not rational. So these are numbers that don't fit that rational description. So they cannot be written as a fraction. And then as a decimal, they do not end or repeat. So they're either going to go on, they're basically going to go on and on and on forever, or be random numbers. So let me give you some examples of this. The first one would be pi, which is 3.14159, and it keeps going. Okay, there's no pattern there of numbers. It's just random, and so it doesn't repeat and it doesn't end. Thus, it is an irrational number. Another one could be -3. Oh, sorry. Let's not do that one. Let me give you a different one. Oops. Let's say the square root of 10. Okay. Now, the square root of 10 does not have it's not a perfect square. In other words, like 3 squared is 9, so the square root of 9 would be 3. It doesn't have anything like that. If I were to put it in a calculator, I'm going to get a funky decimal answer. Same thing with square root of 3, that would be 1. Okay, here's a visual I made for you. Well, I didn't make it. I stole it from someone else who made it. But basically, real numbers is all existing numbers. And that's what that real numbers thing is here. Here we have our rational numbers on this side, and then we have on the opposite side our irrational numbers, and those are the two kinds of numbers. And then, as you can see, there's lots of examples there for you. Through the rational side, okay, we have integers, we have whole numbers, and then we have natural numbers. And so you can kind of see that laid out too. It's just what I talked about, but it's just another visual for you. Alright, your turn to practice. Please identify these as rational or irrational. And then if it is rational, please include the subcategories like whole, natural, and integer. So please decide what each of these three numbers are, and then check in with me when you're done. Alright, here are your answers. Just going to briefly highlight the first question. The square root of 25 is actually 5, so that means it is rational. It is a whole number. It is a natural number or a counting number, and it is an integer. If you have questions on these, be sure to bring them in class, but it's pretty straightforward you just have to know what fits what. And this is the end of your video. Thank you for watching. Have a wonderful day.